This lesson deals with Supplemental Problem 6.4. You can find this problem in the course ebook in the Chapter 6 Supplemental Problems on page 4. Around page 21 in the Chapter 6 notes, we introduced a second-order high-pass filter. Here's another variation on that filter. Let's see if it works. When the frequency gets very low, the inductor looks like a short, and the capacitor looks like an open. The short circuit here is going to force the voltage here to be 0, and the open circuit here is going to limit the current that can flow in this short circuit to create a voltage. There's two things that are pulling you down as the frequency gets lower and lower. As the frequency goes up, this becomes an open circuit, this becomes a short circuit, and we pass the signal. It does look like a high-pass filter. Could you solve for the ratio of V out to V sub S, and then use that to find omega naught and Q naught? We have a voltage divider with this impedance with the capacitor. V out divided by V sub S would be equal to this impedance over this impedance plus the impedance of the capacitor. Product over sum, j omega L times R divided by j omega L plus R, in the same term, and then plus 1 over j omega C. Let's multiply numerator and denominator by this term j omega L plus R. This is going to give us just j omega LR. This term will become j omega LR. And then we'll have this term times this one. Here's the j omega L plus R times 1 over omega C. Now multiply numerator and denominator by j omega C. I'm going to get j squared, which is minus 1, omega squared, and then L times C times R. Same term will be over here. Then multiplying through by this, we just have the term j omega L plus R. Divide through by R, the numerator and denominator. It's left with minus omega squared LC, minus omega squared LC, j omega L divided by R, and then a 1. Does this look like our form that we had on Chapter 6, page 21? The answer is yes, and we can compare terms to figure out what is omega naught and Q naught. The numerator term, omega naught squared is equal to 1 over LC, and omega naught is 1 over the square root of LC. This term over here, omega naught Q naught, is equal to R divided by L, divide through by omega naught, and so then Q naught is equal to R divided by L, and omega naught is 1 over the square root of LC. And you could write this as the square root of L squared, and then one of those L's would cancel with this. We just have R, and the square root of C divided by L. And this is Supplemental Problem 6.4.